In this video, we are going to have an application on solving equations, wherein the equations that we will be getting usually have parentheses, and then it has to do with consecutive integers. Alright, so we have here three situations, wherein first situation is we find three consecutive integers with a sum of 36. So three consecutive. Consecutive means that one after the other. Example, we have 1, 2, 3, 5, 7, 5, 6, 7. So they are in correct sequence, right? Now the second situation is we're going to find three consecutive odd integers with a sum of 75. So this time, remember, we have even and odd integers. So we have to know the relationship between odd integers and how is it different from consecutive integers. All right. And then the third one is finding three consecutive even integers with a sum of 78. So we have one is we simply are looking for three consecutive integers. Second, we are going to find three consecutive odd integers. And the third, we're going to find three consecutive even integers. All right. So let's find out what are the similarities and differences of these three situations. Let's start with finding the three consecutive integers with a sum of negative 36. All right. So because this is a word problem, we have, according to the standards, we are going to use variables to create an equation and solve this particular problem. So that is according to standard A.CED.A.1, that is to use or write an equation using variables to represent the situation, and then we're going to solve the equation to find the unknown in the problem. Alright, so first thing, we have to find out what the situation are. So we have to find three consecutive integers, so they're consecutive, right? And then with a sum of negative 36. So when we say sum, that means it's the result of adding. So which means, okay, the result of addition. So which means that we will be adding these three consecutive integers, and then we will get a sum of negative 36. But what are these consecutive integers? They are unknown, so we will have to represent our unknown with a variable, and let us say we use x. So let's define x. So because they are consecutive, so there's always what we call the first integer, the second integer, and the third integer. Okay, so we usually represent the variable as the first integer. Okay, so first integer. So if x is the first integer, how are we going to represent the second integer? So let's think. If our first integer, okay, let's put this to the side. If our first integer is 4, what's going to be our second integer, meaning the integer next to 4? It is 5. All right. So how do we get the next integer if our first integer is 4? We simply have to add 1 to 4 to get 5, right? And then if our second integer is 5, the next integer is 6, and we know we will have to add 1 to 5 in order to get the next integer. So that means for consecutive integers, their common difference, or we simply need to add 1 to a particular integer in order to get the next integer. So here, if x is our first integer, then our second integer is going to be the first number or first integer plus 1. Then, since we already have the second integer, then we can represent our third integer as, okay, so it's going to be the second integer, which is x plus 1. And then we have to add 1 again, right? Because the second integer is x plus 1, so the third integer is going to be the second integer, which is x plus 1. So take note, I use the parenthesis there to represent the second integer, and then we add 1. Well, we can simplify this actually. That will just be x plus 1 plus 1, or simply x plus 2. So we will be using x plus 2 to represent our third integer. All right. So now we have represented the first integer, second integer, and the third integer. And we will have the sum. So which means you will have to add your first integer, your second integer, and your third integer all together. So what's the first integer? It is x. Then what's the second integer? It is quantity x plus 1. Then what's the third integer? It is quantity x plus 2. And so this is the representation of the sum, and it says the given sum is negative 36. So this expression will be equal to negative 36. So this is now our equation, which is derived from the given situation. All right, so now let's solve. So here we have parentheses, and each group is not multiplied to any numbers. So by virtue of the associative property, we can just remove the parentheses. So now we have x plus quantity x plus 1 plus quantity x plus 2 equals negative 36. What property did we use? The associative property of addition. Okay, an associative property. All right, so now we can combine like terms. What are the like terms? We have x, x, and x. So x plus x plus x, we have 3x. Then we also add the constants. We have 1 and 2. 1 plus 2 is 3, and that's equal to negative 36. Okay, so after combining like terms, we now have 3x plus 3 equals 36. We need to get the 3x by itself, but because it's added to 3, then we will have to subtract 3 from each side of the equation. I have a space here, so I can just simply do my subtraction directly. There you go. And that is by the subtraction property of addition. Sorry, subtraction property of equality. All right, simplifying, we now have 3 minus 3. This part here will just be equal to 0. And what's left is just simply 3x. And that's equal to, now we have negative 36 minus 3. Okay, that will be equal to negative 39. Well, when you subtract a number, that's the same as adding the opposite. So negative 36 minus 3 is just the same as negative 36 plus negative 3. So negative plus negative, just simply add these two negative numbers, so you get negative 39. So now you have x multiplied to 3. So divide both sides of the equation by 3. The number multiplied to x. So we get now x equals negative 13. So this part here, that's the division property of equality. Okay. So x is equal to negative 13. Now, that is x. So let's go back to our representation. What does x represent? From our definition of the variable, we say we let x be the first integer. So the first integer here is negative 13. So if the first integer is negative 13, what's the second integer? The second integer is represented as x plus 1, but x is negative 13. Then plus 1, that's equal to negative 13 plus 1 is negative 12. Alright. Okay, so the second integer is negative 12. So what's our third integer? The third integer is represented by x plus 2. So x is negative 13, and then plus 2, that's equal to negative 11. So we now have the three consecutive integers, namely negative 13, negative 12, and negative 11. So the three integers, consecutive integers, are negative 13, negative 12, and negative 11. Alright, so take note. We use parentheses here to group the expression representing the second and the third integer, and we remove the parentheses because each group is not multiplied to any number, and we were able to do that using the associative property of addition. Alright, and then proceed with the simplification. Alright, let's move on to the next situation. Alright, I'd like to do the consecutive even integers first. Okay, so this time, unlike with the first, we were asked to find just the three consecutive integers. This time, we are asked to find consecutive even integers. Okay, let's have an example of consecutive even integers. So if we have 2, so the next number will be not 3 but 4, because 3 is odd. Then so we have 4, the next even integer would be 6, so that's 3 consecutive integers. Another would be 10, 12, 14. Alright, so if you take a look, how will you get to the next even integer if you're given one even integer? So from 2 to 4, we notice that we add 2 to 2 to get 4. If we have 4 to 6, we have to add 2 to 4 to get 6. So which means the difference between even integers is 2, right? Just like 10, 12, 14. So you have to add 2 to 10 to get 12, add 2 to 12 to get 14, add 2 to 14 to get to the next even integer. Alright, so with that in mind, so we will have to represent our integers. Alright, so again, we let x be our first even integer. Alright, and then, so if x is our first even integer, how are we going to represent our second even integer? So take note, from 2 to 4 we have to add 2. From 10 to 12 we have to add 2. So therefore, if x is our first even integer, then our second even integer will be x plus 2. Alright, then our third even integer will be the second even integer, which is x plus 2. Then we add another 2. So x plus 2 is our second even integer. Then we have to add another 2 to get to the third integer. Okay? Just like from 2 to 4, we add 2. From 4 to 6, we add another 2. All right, let's simplify this expression. X plus 2 plus 2. So that's simply x plus 2 plus 2. Or that's going to be x plus 4. All right. X plus 4. That is our representation for the third even integer. So now let's get the sum. So because we have 3 even integers with a sum of 78. So which means we will need to add the 3 even integers. So our first even integer is x. Then our second even integer is x plus 2. Then our third even integer is x plus 4. And the sum is given to be 78. So this is our equation. All right. So now, in order to find the even integers or the value of x, then we will have to apply the properties. Again, we have grouping signs here. We have parentheses, and the groups are not multiplied to any numbers, so we can just simply remove them. So we have x plus 2 plus x plus 4. That's equal to 78, and that is by virtue of the associative property of addition. All right. Then, combining like terms, we have x plus x plus x. We have 3 x's. So that's going to be 3x. And then we combine the constant. 2 plus 4 is 6. And that's equal to 78. Okay, now we have to get the 3x by itself. But because it's added to 6, so we have to remove the 6 by subtracting 6 from each side. That is by virtue of the subtraction property of equality. Okay, and then simplifying 6 minus 6, that's going to be 0. And what's left on the left side will just be 3x. And simplifying 78 minus 6 is 72. Now we divide both sides of the equation by 3 because x is multiplied by 3. We have divide 3 here, we divide 3 here, and that is by the division property of equality. Okay, so simplifying x 3 divided by 3 is 1. 1 times x is x, and 72 divided by 3, that will give us, okay, should give us 26. Yeah, 20. Oops, hold a second. Pause. Right, so 72 divided by 3 should give us 24. So we have x is equal to 24. All right, so what we have here is just the value of x. We haven't actually answered the question yet because we are asked in the problem to find the 3 consecutive even integers. So we go back to our representation. Remember, this x here is our first even integer. So that means our first even integer is 24. And so if 24 is our first even integer, then the second even integer is 24 plus 2, or 26. And the third even integer is 24 plus 4, or 28. Therefore, the 3 consecutive even integers are 24, 26, and 28. Alright, this time, let's find 3 consecutive odd integers with a sum of 75. So the difference between odd integers, this is for the consecutive even integers. Okay, representation are the same. And then we have for the consecutive integers, just simply the ordinary integers. Okay, hope you get it and practice.